as a few excellent papers have pointed out, the first one in 2009 by the late Will Stephan, the risk, the ultimate risk, has been called hot house Earth, a superheated planet, which nobody could survive. And that leads to what's being called runaway climate change. And it's a situation in which our global warming is causing so much amplification by so many feedbacks that we've lost even the opportunity to control.
And welcome to another Climate Emergency Forum. Today our show is Risk in the Climate Casino. And those of you who are regular watchers, and if you're not, subscribe, but those of you who are, know that when we talk about the climate casino, the house always wins. So risk assessment, it's a huge, huge topic and encompasses many aspects related to climate change and specifically how climate change will affect us. Make no mistake, it will affect us all on any number of fronts. Many people think that climate change is just about it. You know, it's getting, maybe fall starts a little later, maybe there's less snow, and that is a part of it, of course, depending on where you live. But there's so many other aspects. We know that with drier weather and with hotter heat, there is a likelihood of forest fires. And we have seen many of those. One of the wealthiest states in my country, the United States, is California, which I believe is still holding on to the lead of the fifth largest, wealthiest economy in the world. It's crazy. That's just one state in the United States. One of the things that distinguishes California, besides its natural beauty, is housing. It's very, very expensive. And of course, you want to protect your most important asset. But in May, State Farm said it was no longer going to take new applications for housing insurance in California. And after that, Allstate followed suit and said they're not going to do it either. The buyer beware. It's very rare to find a home under $1 million in many parts of California. Can you imagine spending the greatest amount of your personal wealth to buy a home and then to find out it's uninsurable? But it's not just California, it's also Florida. Florida has tremendous amount of issues, as we know, with many tropical storms, hurricanes, rain, flooding. A lot of issues too are in Louisiana. A lot of people don't think about Louisiana. We have one of the largest ports in the country in Louisiana, that's in New Orleans. Some beautiful property in Louisiana, but unfortunately, a lot of Louisiana is built on a swamp, and the Gulf of Mexico is continuing to swell, and the Mississippi River is continuing to rise and is several feet above New Orleans city proper. So it's really just a mess. It's just an absolute mess. I didn't mention all the states. We also have Texas, one of the largest states in the union. They're having a lot of problems. I think a lot of you probably remember Hurricane Harvey. Tremendous amount of homes in Houston got flooded. And once those homes get flooded, a lot of them have cheaper materials. You have mold growth, especially due to the hot, humid climate. And so many of those homes are just simply not salvageable. But I'm going to go ahead and cover the third coast, the one coast, and that's New York City. We were hit with Hurricane Sandy. So much of my country is going to be, many of homeowners are going to have a hard time finding insurance. And I want to turn it over to Peter. Peter, what are your thoughts on risk assessment? I know that you're in Canada, but you also have seen extreme weather.
Oh, yeah. I mean, we sure have. Yeah. Fires and rivers of moisture. Yeah. So, yes, indeed. There's really nothing more important than risk in general terms, right? to live in a safe community and use products which are safe. So what I know about risk, of course, goes back decades to my medical work and also work in air pollution that I got involved in a long time ago. So the first thing I should say is that the IPCC does not do risk. It completely rejects risk and it contradicts risk. So I can just give you two examples. They're very simple. The largest risk of climate change, specifically of global warming, are the feedbacks. And the largest of the feedbacks, which we've known and worried about for decades and decades, are the methane and carbon dioxide feedbacks, which occur as a direct result of global warming. And they occur first in wetlands, which are all over the planet, and then later on they'll occur with permafrost, which melts. So we've always known this, we've always worried about it. But those have never been included in the projections of the IPCC assessments, right? Never. Even in the most recent sixth assessment, just 2021. The other example is that the IPCC has always used one fundamental metric in projecting climate change impacts and what's going to happen. They call it the climate sensitivity. It's what happens to the temperature with a doubling of atmospheric CO2. They have always used only one number, and the number is 3. And there's a big range of possibilities, but they do not include the possibility, if not probability, that number will be 3.5, which would make a huge difference for future impacts, 4 or 4.5. So there's two examples, absolutely scandalous examples, of why the IPCC does not do risk, it ignores it. In fact, as a result of the IPCC assessments, we have continued to expose ourselves to increasing and massive risks from global climate change impacts, and we've already mentioned those. So we are far beyond risk of climate change. We are experiencing disasters and catastrophic impacts of climate change. So why have we allowed that to happen? Well, particularly in the United States and Europe, for many decades, we have, the professionals, as you referred to, have worked out a very reliable and excellent methodology for risk, particularly in environmental health risk. I had a paper published back in 2019, and if anybody wants to really know about climate change risk, I'm not telling you to go to my paper, it's way too long. But I used a 2010 publication, which is absolutely excellent, by the National Institute of Environmental Health Services in the States, a human health perspective on climate change and risk. And the IPCC has obviously never looked at that document. So the key thing, of course, about risk is the magnitude of risk. So we have always had a very simple definition, workable definition of what risk is. It's the product of the magnitude of a risk times the probability of the likelihood of the risk. Now, actually, years ago, the IPCC did quote that risk definition. Didn't do it, but it quoted it. With the last assessment, it rid itself of that definition. And the last definition by the IPCC is a very vague one, in which they say that risk is the potential for adverse consequences. So there's no number there, there's no rating. So why do we do risk in environmental health assessment? For regulation, for regulation. So the government or the environmental department will hear about a chemical that's being produced, and there's concerns that it might be hazardous if it's distributed in all the air of the planet or all the water of the planet. So the teams get together and they do an environmental health risk assessment on pollution. Now, I think there's only one person other than myself who has pointed out that the problem with climate change is pollution. And the environmental health risk assessment and regulation deals with pollution. So Unfortunately and ironically, in deciding that it was going to be climate change that we assessed, the science of pollution has absolutely been ignored. And there is, of course, no regulation whatsoever on climate change. Quite amazing because the United States EPA did a very good risk assessment in 2009 or 10. So that's all I'm going to say, but I just want to point out that we have methane feedback. We have wetlands all over the planet emitting huge amounts of methane. It's driving atmospheric methane up at an explosive rate. If we had treated climate change as we treat any environmental health pollution problem, we would never have allowed this to happen.
Peter, thank you so much for bringing up the risk to beings who breathe. Of course, we all care about our possessions, our home, our shelter, but of course, just being able to live shouldn't be considered a luxury. And it's extremely important. And the fact that, as you've mentioned many times on this show, anywhere between 8 to 10 million people die every year due to the combustion of fossil fuel. What greater risk is that? If we don't value that, what can we possibly value? Of course, we know the numbers of human beings who die because of the pollution due to fossil fuel combustion, but we don't really keep track so much of everyone, of all other living beings that die. I guess that's certainly even less important. And what a reflection on us. Paul, I'm really interested to hear what you have to say on this. I know that you coined the term the climate casino, which we all just love. And I'm interested to hear your take on risk assessment.
Thank you. So, I hear the word pollution from when Peter is talking, and, the old moniker, dilution is the solution to pollution, used to be what people would think, use a smokestack, bring up the pollutants, spread them far and wide. But we've clearly found out the cumulative pollution from fossil fuel burning has changed the chemistry of the atmosphere and oceans, the way that heat is transferred on the planet. And we're living in a world of extremes, and it affects everywhere on the planet. And this is why, we're all living in the climate casino. If we get unlucky, our cities can be flooded out. We can lose our places of employment. We can lose our livelihoods, even our lives, our homes, etc., from the disruption in the climate casino. So, it's very important to go back to the roots of what risk is. It's, as Peter mentioned, it's the probability of occurrence times the impact or consequences if that event occurs. And we're not very good as a society at assessing risk, any types of risk, but we're even worse when the probability is very, very low of something happening, the consequences are very high. So the best example I have is, the probability of an impact of a rock from space, a comet or asteroid, hitting the Earth is very, very low. The probability is very, very low, but the risk, the consequence is extremely high. It could be, the entire planet. So when you multiply a very small number by a very large number, there's a lot of uncertainty just from the math. So we tend to, when there's a lot of uncertainty, we tend to ignore things. We're very good at ignoring things. And we've tried to ignore climate change for many, many years, thinking that, well, it's a 2100 thing. Probability of tipping points, of catastrophe is very low, even though the impact is very high. But now we've seen, the world is experiencing extremes. This year, it's really ramped up. People are starting to get worried. And so the probability of occurrence is becoming very, very high, and we're living it with climate change. So we've always assessed risk poorly. The biggest risk of somebody taking a flight somewhere is the drive to the airport. The drive to the airport is the highest risk, getting in a car accident. The risk every day to people is highest from basically things mundane like crossing the street, walking on the sidewalk next to the street. The risk of having something happen to you doing those things is extremely high because the probability is high because we do them every day. And there's a lot of careless drivers out there. Evaluating risk, it also comes down to sort of the value we put on a human life in the future. For example, I mean, a paper has just come out that is talking about 1 billion deaths by this century from climate change, numbers like that, huge numbers that are hard to wrap the human mind around. So we've tended to just collectively ignore climate change, maybe hope that some technology would come around to, solve it. We all grew up on cartoons and comics of superheroes, that would continuously in each cartoon rush around and save the planet. And we have this sort of unrealistic expectation that scientists will, if the problem gets bad enough, then somebody will solve it. And we're not seeing that happen with climate change. It's getting worse and worse, and governments, the worse it gets, we tend to make excuses for not acting. So, we just don't evaluate risk very well. I mean, there are experts, there are actuarial experts working for insurance companies, working for military, working for governments on the risks of things happening. And we tend to just consider the numerator, how many people are killed by terrorism, as opposed to how many, the numerator divided by the denominator, the number of people killed by the total population. And if we did that correctly, we would have not spent years and years panicking about terrorism, because the risks were still way, way lower than, say, from heart disease or car accidents or anything else. So in order to try to mitigate risk, we need to evaluate it properly. And because there are a lot of ways to mitigate risk depending on, but we have to be willing to spend money to do that. And we're clearly not doing that as far as climate change is concerned.
Thank you, Paul, for sharing your thoughts. I mean, it's really true. You brought up terrorism. I'm a New Yorker, and of course, that's something that we've experienced a lot of. It's something to be taken seriously, and I know that you know that too. But when you look at the tremendous amount of resources that we've put into this, and if we look at how few resources that we put into the very, very real living risk that we face daily of climate change, that's what boggles the mind. I mean, if we look at how many people are killed by terrorism, of course it's a terrible thing. But does it come close to 8 to 10 million people every year? I don't even want to examine what that means about these multinational corporations. But maybe you can extrapolate for yourselves. Peter, I'd like to hear what more you have to say on the subject.
So when risk is rated for environmental health for populations, there's such a thing as a zero tolerance risk. And that's a situation where a chemical, for example, is banned by the government. It's so hazardous to so many people, like all over the world, particularly children, in most cases, that particular chemical is banned. It's not allowed to be produced. When I did my paper a few years ago on climate change as environmental health risk, I couldn't find a study on fossil fuel risk. I could find plenty of studies on business risk of fossil fuels, or like risks of investing. I could find things on risks involved in extraction by particular complicated methods, but I couldn't find a risk assessment for fossil fuels. So the zero tolerance risk of fossil fuels then is what I mentioned. It's global warming feedbacks. And climate change is a unique and a uniquely dangerous situation because it has long, long lag times. James Hansen has described that I don't know how many times. And it has intrinsic within the nature of the global warming on the planet the potential to amplify itself. And one of the ways it does that is with feedback. So we are now accepted a zero tolerance risk of climate change to the entire human population, most of life on Earth, and all future generations. We have methane feedback operating. It's coming from all over the planet. It's coming from northern wetlands, which scientists thought would be much, much later. But there are vast wetlands in the north, in Russia and northern Canada. They're coming from the Amazon. They're coming from the Sudd in Africa. They're coming from the Central African jungles. They're coming from Indonesia. They're even coming from China and India that has large wetlands, and even England, which was covered in a brown methane map when I looked at the Copernicus map. They're all emitting all over the world. It doesn't seem that anybody's particularly interested in this fact, because this is a zero tolerance risk, not just to ourselves, but the entire future of the human race. And it's a zero tolerance risk to all of life, because, as a few excellent papers have pointed out, the first one in 2009 by the late Will Stephan, the ultimate risk, has been called hothouse Earth, a superheated planet, which nobody could survive. And that leads to what's being called runaway climate change, which the scientists and the IPCC sort of reject and don't like to talk about, but we all understand it. And it's a situation in which our global warming is causing so much amplification by so many feedbacks that we've lost even the opportunity to control. And this was pointed out by who is probably the world's expert on methane, Ewan Nesbitt out of the UK. And he has been excellent in pointing out the massive risk of what's going on at the moment with this methane feedback. We've even got methane hydrate coming out of the Arctic. It started coming out of the Kara Sea a couple of months ago. So we've got to look at risk, but we've got to rapidly realize that we have ignored risk for so long, for decades, that now we're into zero tolerance risks and catastrophic, globally catastrophic impacts. One, of course, is the fires going across the Boreal in Canada and Siberia. I mean, I find it just absolutely incredible that here we are 30 years after the government signed the Convention on Climate Change. And what are we doing? They're subsidizing fossil fuels more than ever. $7 trillion a year. The IMF now estimates that governments are subsidizing fossil fuels with. So we're allowing our governments and corporations to literally destroy our future and ruin our wonderful planet. Very sad.
Very sad and very succinctly said, Peter. You know, I learned a lot through what you just said. I always learn every time we do come together to do a forum here. I learn something. And I really, really appreciate that. There's so much. This is such a complex subject, and there's so many areas of study. You could spend a lifetime and still learn more. And so I want to thank all of you who are here to learn, because it's very, very important to do that. We need educated people on this subject. It's very important. So if you learned something on this video, please be sure to share it with someone who you think may be of benefit. Maybe they're living in a state where it's getting harder and harder to insure their homes or even their cars. And if you haven't subscribed, please do. Well, let's get in a final few words from Paul here on this risk in the climate casino.
Yes, thank you. So at the risk of traumatizing our listeners and everybody, I'll take you back to grade school. And after grade school, high school, you know, hopefully some good memories as well as bad memories for some people. But everybody knows about the bell curve, right? That bell curve, you know, if you flunk a test or exam and you talk to all your friends and they seem to have done worse, then you're probably okay, because the marks will be belled up and you'll end up passing, right? So it's sort of a distribution curve, and it peaks in the center and it drops off on either side. Scientists, mathematicians call it the Gaussian curve or a normal curve. So what's happening with climate is, we have an average temperature in the middle of this bell curve, but then in the far right wings, there's much, much higher temperatures. And as the whole curve shifts over to the right, you get more temperatures following above a threshold, for example, with heat waves, or if what's being measured is precipitation levels, you end up in the far right wings of the bell curve and you get torrential rains, and those are happening much more often as the extremes of climate increase. So in terms of disasters, we're operating in the wings of this bell curve much more often in the far extremes and getting all kinds of extreme weather. And the probability of this extreme weather is increasing because of the statistics, and also the intensity of the extreme weather is also increasing, whether it be torrential rainfall or droughts in other places leading to crop failure, etc. You've all heard event X, whatever. Flooding is a 1 in 1,000 year event, or a 1 in 100 year event, or a 1 in 500 year event. It's not supposed to happen frequently, but when you get 3 or 4 1 in 1,000 year events happening in the space of 5 to 10 years, you know that something is out of whack. And what that is climate stationarity. We used to be able to when we had a stable climate, there would, of course, be extremes on either side, cold or warm, or more rain, less rain, but they happened within a range which we could build our societies on. We built our homes, our roads, our piping, everything in our society based on this climate stationarity. And now we no longer have such a thing. So, like I said, the idea of 1 in 100 years or 1 in 1,000 years, we need to throw those concepts out of the window, because we're undergoing a sharp transition to a much more extreme world, extreme climate. So the risk assessment needs to be redone, and it's very hard to do when the goalposts keep moving. So because the warming is accelerating so rapidly, from not just from our own emissions, but from feedbacks, which James Hansen's often talked quite a bit about in some of his most recent papers, and I refer you back to those to have another look. But we're hitting a world of extremes where the risks are much, much higher and are much, much more difficult to evaluate. And this is why the metaphor for climate casino, we're all basically in a climate casino, and the risks are much harder to pin down and know, but they're much, much higher than they used to be in the past. So we need to be aware of that moving forward, because we're living in a world of consequences as opposed to projected climate problems. They're here, they're happening, they're happening much, much faster, and they're much more intense than people have expected and prepared for. So our society just is not ready for what's coming down the pipeline. As Hansen pointed out in his last paper, the next couple of years, we're very, very likely to have another ramping up of extreme weather events and climate catastrophes on our planet.
Thank you. Thank you so much, Paul. Thank you, Peter and Paul. And I'm really glad that you ended on a strong note of quoting Dr. Hansen and his paper. I would like to say that we'll have that in the description for you so that you can go ahead and find that PDF rather easily. Very important reading. And I think what Paul said, we are living the consequences now. We don't really need to talk about the future of climate change. We really should stop that type of verbiage, because it's false. It's now. And I want to thank you so much, as I mentioned, for being here with us. And I'm curious what risks we may not have mentioned that you think should have been mentioned. And for those of you who are living in states where new policies are not being offered to homeowners, or if you've seen a drastic rise in your insurance, please share that with us. It's good to see your actual living experience, and we can have a lively discussion down in the comments. I want to thank you once again for joining us, and we'll see you next time at the Climate Emergency Forum.